Now, in the questions that we have been looking at so far, we have been um, resolving problems where we have straightforward probability questions that we have to work out or evaluate. Now, what if you're actually given the probability, but you now needed to figure out what was the unknown value that determined the area below the graph that you're trying to work out. So here we're asked, what is that unknown k such that the area below the graph up to that point gives us a probability value of 0.6. If we were to put this in diagrammatic form, we're going to have something that looks like this. So we're given a normal distribution. The mean is 35 and the variance is 4 square, or the standard deviation is 4. The total area less than k is 0.6. So we know that left of the mean is 0.5. So that means that k must be slightly to the right, so that the total area is 0.6. If we had placed k over here, it wouldn't be correct because you get a value that is less than a half. And we need a value that is more than a half. And to get a value more than a half, it means k has to be bigger than 35. So what would we do here? Now, again, a couple of strategies are available to us: a calculator strategy and a tabular approach. The calculator strategy is fairly straightforward. We will now use the inverse normal. So let me pause here and draw an analogy with trigonometry. So in trigonometry, sometimes you'd be given a problem like this. Solve for sine of 30 degrees. So if you're given sine of 30 degrees, you'd put that into your calculator, and then you know that sine of 30 degrees is equal to 0.5. But let's say they told you that there is a value whose sine is 0.5. What is x? Now, you can't use sine, you have to use the opposite of sine, inverse sine, sine to the minus 1 of 0.5. And now you can get x to be equal to 30. So just as we use inverse sine, if we're given the value of sine but not the angle, we can use inverse normal if we're given the probability but not the extent of the domain. So how would we now proceed in order to evaluate this problem? So what we would now want to do is we want to do inverse normal. So here, if x is less than k, implies that k is equal to the inverse normal of 0.6, given that mu is 35 and sigma is 4 and the area is equal to 0.6. And this is the area. This only works if the area is leftward facing. So again, we go to our calculator. We're going to go to statistics. Then we're going to go to distribution. It might be different on your calculator, so you want to use the appropriate routine for your calculator. Then we go to normal. And then I'm going to now go to inverse normal, INVN. The area is the area to the left of the unknown domain value, which is 0.6. Our sigma is 4, and our mu is 35. And so here, this gives us the unknown domain value. Therefore, k is equal to 36.013. And that would complete the question. Now, this is the most direct approach for solving this type of inverse normal distribution problem, where you're given the probability, but you're given an unknown x value that needs to be determined. Again, we can use a tabular approach, and let's walk through the tabular approach, and we'll put the solution here that we can check against, 36.013. So in order to use the tabular approach, we'll need to convert this to Z statistics rather than X statistics. So we're going to use the fact that Z is equal to X minus mu over sigma. All right. So the probability that X is less than K will now become the probability that Z is less than X becomes K minus mu. Mu is 35 over 4. And that's equal to 0.6. All right. So K minus 35 over 4 is equal to, the symbol that we use is 5 to the minus 1 of 0.6. All right. So that would be like sine inverse or tan inverse or cos inverse. 5 to the minus 1 is our inverse normal, in particularly used when we have Z as, so this is for Z following a normal distribution when we're using the Z random variable, the standard normal variable. So phi inverse of 0.6. So again, we can go to our table and we look for 0.6 in the row and 0, 0 in the column. And we should get K minus 35 over 4 to be equal to 0.758. Let me just, so 0.6 would be 0.72, 0.72575. So once we've determined that value, now what remains is just a straightforward algebra problem where we rearrange for K. So if we do it in 2 steps, K minus 35 is equal to 4 times 0.72575, and then we add 35 to both sides. So K is equal to 4 lots of 0.72575 plus 35. So we now evaluate that. So 4 times 0.72575 plus 35, and that will give us K is equal to 37.903. All right, so let's check this out.